In this lesson, we're going to look at a concept called percentiles. And in this video, we're going to look at working with percentiles and something called the percentile rank. And we're also going to look at solving problems involving percentiles. The outcomes we're going to cover include explain the relationship between the median and percentile, explain using examples percentile ranks in a context, and explain using examples the difference between percent and percentile rank. So what is a percentile? A percentile is a value below which a certain percent of the data set falls. So for instance, if we're at the 30th percentile, 30% of the data in a given set would be less than whatever that value is. The median, if you recall from a previous video, the median is the halfway point. Half of our data is larger than the median. Half of our data is less than the median. So the median is called the 50th percentile because, like I said, half of the data, or 50%, half of the values would be less than the median value. And a percentile rank is a number between 0 and 100 that indicates the percent of cases that fall at or below that score. So it's essentially the same thing as percentile. So here's our example. Sierra wants to apply for a scholarship so she can attend college. Her cumulative average must be in the 75th percentile of her class to qualify. Below are the cumulative average scores of her class. So what we're going to want to start with is constructing a stem and leaf plot for the data set. I've included the data here. If you recall from a previous video, we constructed a stem and leaf plot before. So the stem and leaf plot works. We look for starting off the lowest value in the table, and that would be right here, 34. That's the lowest number in the set of data. So my stem and leaf plot starts with the number 30. The tens would become a 3, 4. My leaf would be the 4. So again, the tens digits are the stems of our stem leaf plot, and the ones digits in our numbers are the leaves. So we can continue that trend, and when we do, I've got the completed stem and leaf plot done here. It includes all the numbers. This is my stem and leaf plot. So we have 34, 45, 46, 52, 54, 58, and so on and so forth. You'll notice that the 70s are the most common numbers. We have 71, 71, 71, 72, 74, 75, 75, 76, 76, 77, 77, and 77. Next, we're going to want to determine the median. So to do that, if you recall from, again, a previous video, what we would have to do is start by crossing off the end terms in each case. So we start by crossing off 34 as well as 94. Then we cross off the next lowest, which is 45, and the next highest, which is 89. Next lowest, which is 46. The next highest, which is, again, 89. And we continue that until we either get one or two pieces of information left behind. Now in this case, I've counted this up already. There are 30 total values in this stem and leaf plot. So when I complete my stem and leaf plot, or when I complete the canceling of the numbers in my stem and leaf plot, this is what I should end up with. So what you'll notice is that I'll end up with two numbers in the middle. I'm going to have 74 and 75 in the middle of my stem and leaf plot. So because it's an even amount of data, I'm going to end up with two numbers in the median. That means I'm going to have to find the average of those two numbers. So the two numbers are 74 and 75. The average would be to add them together, divided by the number of terms, which is 2. 74 plus 75 divided by 2. which works out to be 74.5. So what that means, again, is that half of my data, or 50% of the data, is going to be larger than 74.5. That would be, for instance, 75 and 76, and this 75 as well, 76 again, 77, 77, all the way up. So basically, the amount of data I have is split right here. Half of my data is larger than this line or above this line. Half of my data is below that line. The next question asks, what is the minimum average Sierra needs to qualify for the scholarship? Well, she needed, if I go back to the right slide, she needed to be in the 75th percentile in her class. So that means, oh, not gone far enough. Here we go. All right. The minimum average she needs is the 75th percentile, and the 75th percentile would be halfway between the 50th and the 100th percentile. 75 is halfway between 50 and 75. So I've already darkened or lightened the bottom half of my data. I'm only worried about right now the top half of my data, from 75 up to 94. Once again, I'm going to have to find the median value of my top half of my data. So basically the median of the top half of my data. So once again, I'll start crossing off numbers. I'm going to cross off 75 and 94. Then I'm going to cross off 75 and 89, 76 and 89, and so on and so forth. And what you'll find is that I have all my data crossed off. I'm left with this leaf right here, the one when my stem is 8. So in other words, 81 is my median value for the top half of my data. The 75th percentile would be 81. So Sierra will need to have an 81 cumulative average in her course in order to qualify for the scholarship. Next question, what is the percentile rank in for a cumulative average of 58? Well, you'll see that 58 is right here on my data. So 58 is the 6th number. If we start from the lowest value, which is 34 right here, this is my lowest value. So 58 is the 6th value in this set of data. And there are 30 data values in total. So if there are 30 scores in total in this class, and 58 is the 6th value when we rank them from lowest to highest, then that means that there are 6 out of 30, or about 20, well, exactly 20% of the scores are at or below this number, at or below 58. So that means the score 58, the cumulative average of 58 in this class, would be the 20th percentile, or 20th percentile rank. And what is the difference between percent and percentile rank? Well, percent is a score out of 100. So if you got a 58 in the class, that means you got a 58 out of a possible total of 100. A percentile rank compares you to the rest of your class in this situation, or compares a given value to all the other values in that group. So the percentile rank is a number stating the number of cases at or below a given score. For example, in the example we just looked at again, The score 58 is the percentage, the score out of 100. But we said it's the 20th percentile. Only if 58 out of 100 is better than 20% of the averages in that class. So once again, what is the relationship between median and percentile? Well, like I've stated before, and I'll tell you again, exactly 50% of our data is at or below that median value. That means that the median value is the 50th percentile. The 50th percentile is where 50% of the data is at or below that value. So the median, we know that half or 50% of the data is at or below the median value. That means it must be the 50th percentile. Okay, so to summarize this lesson again, your percentile is a number that a certain percent of data in a set is less than. The median for any set of data is going to be the 50th percentile, because again, half of the data is less than the median value. It's either going to be the median value or less than. And a percentile rank is the number given between 0 and 100 that shows how much data is at or below a given value.